For our first problem, we have an ellipse. Recall, I don't know if you recall, I don't know that I recall, that the area of an ellipse is a equals pi times a b, where a and b are the lengths of the semi-axes, meaning like halfway along each axis. Suppose that an ellipse is changing size but always has the same proportions, a equals 2b. At what rate is the length of the major axis changing when b equals 12 and the area is decreasing at 144 centimeters squared per second? Whoa, okay. Well, we have a picture. We have an equation that I can't underline because I can't draw straight lines. Just highlight it. We know this, we know this, we know this, and we know area is decreasing at this rate. Okay. So now I'm looking at our picture. Yeah, so this is B, and this is A. Oh, I'm gonna find a better color to highlight the other one. Maybe if we do this nice loud green color. It's hard to show up on there. Oh well. So we have our equation, A equals pi AB. You can differentiate from here. I did try it this way, it'll work. But what you can also do, since A equals 2B, we can just replace A with 2B before we do anything else. Because we're not plugging any values. That's what we can't do, but we can rewrite with different variables. So now A equals pi times 2B times B, which is 2 pi times b squared. Now I'm going to differentiate. So if I do that, dA dt equals, the only variable I have is b, so I'm going to use power rule, multiply my 2, so I end up with 4 pi times b to the first power times dB dt. What do I know? I know b is 12. dB dt, well, that's what I'm not going to be able to find yet, okay? Because I know that dA dt, since it's decreasing, since the area is decreasing at that rate, dA dt is negative 144. Kind of just filling stuff in. So then negative 144 equals 12 times 4 is 48 pi dB over dt. So then dB over dt equals negative 144 over 48 pi. Now, if you were going to find a decimal approximation at this point to your 3 decimal places, you could just remember to put your 48 pi in parentheses. Otherwise, your calculator will do negative 144 over 48 and then multiply by pi, which messes everything up. So now let's look at what we're actually trying to find. We want to know at what rate is the length of the major axis changing when all this is true? Well, the major axis. So the major axis is actually, major is bigger than minor. That's kind of the big thing here. So this is the major axis. The vertical one, because it's shorter, would be the minor axis. So the length of that is actually 2 times 2b, which is 4b. Okay? So if we're talking about 4b, then the rate is also multiplied by 4, since 4 is just a constant. So we actually need to do 4 times dB dt, which is 4 times negative 144 over 48 pi. So then what I'm going to do to kind of simplify here, 4 over 48 is going to simplify to 1 over 12. So I'll have negative 144 over 12 pi. Okay? And that, if you put it in your calculator, is about negative 3.81972. I'm just going to keep, 4 or 5 decimal places, mostly because the rounding gets weird, so 819 with a 7 after it, so I'm going to avoid that issue and keep them all. And so what we know is that the length of the major axis, sorry to pause for my writing, is decreasing because it's negative at a rate of 3.81972, or leave it as 144/12 pi if you want. Check back to units. Centimeters. It's just a length, so it's not centimeters squared or cubed. And it was seconds, so centimeters per second. So there's our answer for our first problem. Now we have rectangle problem. We have a rectangle of length L and width W has a constant area of 1200. The length changes at a rate of dl dt, inches per minute. Now we're looking for at some instant when the length is increasing at a rate of 6 inches per minute, width is decreasing at -2, so -2. We want to find the dimensions at the instant when this information is true. So I'm going to draw a rectangle, try to. Pretend that has right angles and stuff. I'm going to redraw the bottom because it looks kind of curved, which is not a great rectangle. Still not great, I'm going to leave it. Length, width. I know that length times width equals 1200. And if that's true, I also know that length equals 1200 over width. I also could have said that width equaled length over 1200. So you could really differentiate either one of these initial equations. I'm just going to use length times width equals 1200. So we have product rule. So our F and our G is actually L and W, right? So I'll end up with dl dt times W. So that's like our F prime G, plus dw dt times L. It's like our G prime F. Derivative of any number, any constant, including 1200, is 0. So now let's see, what do we know? Length was increasing at 6 inches per minute. So this is 6 times W. And then here, the width was decreasing at 2. So this is minus 2L, or plus negative 2L, equals 0. We have two variables. We want to get rid of one. What do we have? Oh, remember this? L equals 1200 over W. So I'm going to replace it. So I have 6W minus 2, and instead of L, I'm going to make this 1200 over W, and that is equal to 0. So 6W equals, let's see, negative 2 times 1200 over W is negative 2400 over W, okay? And so if that's true, I can multiply by W on each side. So 6W squared equals negative 2400. Divide by 6. W squared okay, I super duper apologize. Erase some steps. This is just like, in real life, you would have been like, what is she doing? Okay, I moved my equal sign in the middle here. This was 6W minus 2 times 1200 over W, so minus 2400 over W equals 0. I realized it because I had to find the square root of a negative number, which is not really a thing, right? We don't want any i's around here. So now if I add 2400 over W to each side, 6W equals 2400 over W. Okay, I can't just randomly move equal signs. It's a good life lesson, right? Times W on both sides. 6W squared equals 2400. Divide by 6. W squared equals 400. Square root of both sides. The width is 20. Normally when you take a square root, you have positive or negative answers, but a width of negative 20 makes very little sense, right? So I know my width is 20. If we go back up here, I know L was 1200 over W. So if the width is 20, L is 1200 over 20. Get rid of those zeros, 120 over 2, which is 60. So the width is 20, or my units, inches, and the length is 60 inches. And that's it.